So what I did here, Dr. Worth, is kind of showed how I approach factoring conceptually at first using algebra tiles, and I'll explain more in my discussion post coming up next. But this part is the AC method, and I usually call it the AC split method. It is one of my favorite methods to utilize because it can be used not only with trinomials with a is greater than 1, but also equal to 1. It also works if you are using perfect square trinomials. And so I used this heavily when I was teaching algebra prep, and then I also use this method as well with in tandem with the algebra tiles when I teach math for elementary teachers, since we're focusing on 6th through 8th grade math standards. And so we use algebra tiles first to start when we're adding and subtracting integers, and then how to add and subtract polynomials, and then of course how to multiply and then divide or factor. So how I did this was took 8 times 3, so I need to find two numbers which multiply to 24, which is 8 times 3, the a value times the c value, but yet add to the middle term of negative 10. And I put in my table there an example of where students might go first, taking 6 times 4, which is 24, but then when I add 6 plus 4, I don't get negative 10. So then it's a play on different ways in which we can multiply and then add to keep track of what we've tried. So in this case, negative 6 and negative 4 work. Those then become our numbers to split the middle term, hence AC split method. So I split negative 10x into negative 6x minus 4x. I now have 4 terms, so I'm able to factor by grouping. So I'll group my first 2 terms and my second 2 terms. Sometimes we see that, depending upon the order I put them in, that I'm not able to have a common factor from my first term or my second term, in which case I would have to rearrange those middle terms. So when I look at 8x minus 6x, I see that their common term that I can factor is 2x, and the greatest common factor of negative 4x plus 3 is negative 1. When I factor those out, my goal is to have a common binomial, which I can then factor out that common binomial of 4x minus 3, leaving me with 2x minus 1. So 8x minus 10x is, of course, the middle of our area, if you will. And now I'm finding the dimensions, which are 4x minus 3 and 2x minus 1. So I need to arrange 8x squared minus 10x plus 3 into a rectangle in order to find those dimensions. So in the middle, I can see my 8x squareds in the middle, but notice off to the right-hand side, I've got negative 6x's in a group which pair with the negative 6x that we had found in our table. Further, underneath, we've got negative 4x's that create the other split term of negative 4x, and then our positive 3. This then gives me our dimensions of 4x minus 3 on the top, and then of course 2x minus 1 on the left.